We are finally on the last section of Chapter 6. 6.10, Analyzing Solutions to Quadratic Equations. And luckily, it's not really that bad. We did some imaginary numbers, and we're going to do some more work with that a little bit. But we're also going to take some of the quadratic formula and use that today as well. So a lot of stuff you'll already kind of know. It's really just applying one small theorem that we're going to get to. So how do you determine the number of roots? So we're still talking about the roots. If you remember what that means how many times it crosses the x-axis or where it crosses the x-axis when we draw a graph. Of course, it's a quadratic equation, so we're talking about happy face, sad face parabolas, right? We're looking at these, right? Happy or sad. So we're going to take a look at that and then see how that correlates with the quadratic formula. We're going to be able to figure out how many roots there are without graphing. But first, let's try it with graphing and see what we come up with. So this example says on your calculator, graph the following equations. We're going to look at the picture of the graph as well as the table. Use the table to plot the points for your sketch. When finished, discuss. Okay, so obviously we can't do that part. This is a video. But I am going to go to Desmos and type this in, and we'll do a sketch of it and bring up a table. Maybe it's just going to be a basic sketch of it. What we really want to see is, looking at these, how many x-intercepts there are. And then we'll figure out what the coordinates of those are. So I'm going to go to Desmos and type the equation in. So the first one's going to be y equals x squared plus 4x plus 3. See what it looks like. X squared plus 4x plus 3. There it is. And I like how it puts the points on here for you. You can actually zoom it in and highlight these here. So we have our coordinates right there. And I think I'll just use those points. It tells us a vertex here as well. That's pretty good. So I don't think we have to bring up a table. So we have -2, -1 is the vertex. And then I'll plot these points. -3, 1, or -3, 0, and -1, 0. All right, -2, -1. Let's do that. So -2, -1 is right here. And then we have -1, 0 here, and -3, 0. So it's, oh man, right here. And then we'll draw the parabola. Oh, well, I really missed that one. Let's retry that. How about right here? It's not so bad now. There we go. So then we can just answer the question down below. How many x-intercepts do we have? Well, we look at this. There's 1, 2. It crosses it 2 times. That's all I'm asking. How many are there? And then we'll state what the coordinates are of those. And then we said, if we looked at the Desmos again, it says -3, 0, -1, 0. So there's our coordinates. It's a little easier to do this than even using the graphing calculator a little bit. We'd have to bring up a table and look and see. All right, let's try -x squared. Let's try that one. So do I want to make a new one? Let's see. Y equals negative x squared. There we go. So it's a sad face parabola here, and we see it coming up and touching its vertex is at 0, 0. So this one comes up and touches the x-axis. Doesn't go through it, but it does touch it at 0, 0. So we only see one specific point that's at the x-axis, and that's 0, 0. And then this one would be -1, -1, 1, -1. So I'm going to plot those couple points on the next one here. So we have our dot here. Let's change colors to red. And then we're going to go -1 here, and then 1 here, and then it's going to go down like this. So this one is a sad face, no big deal. But how many x-intercepts do we have? Well, it only touches the x-axis 1 time. And then the coordinate of that was 0, 0. Okay. So there's going to be one more possibility. Maybe you could think of this. We have this parabola shape every single time, whether it's happy or sad. This time it went through twice. This time it touches 0 time or 1 time. What do you think the last one might be? Let's see. Y equals x squared plus 4. I'll keep that one up there. Let's do y equals x squared plus 4. Oh, I don't even see it. It's because it's out a little bit. There we go. It's in green. So this one here is nowhere near the x-axis, really. It's kind of above it, right? We talked about the shifts. Adding a plus 4 at the end here just moves it up 4 units. So this one has no roots, no x-intercepts. So let's actually draw that. It starts at 4, And I think it just goes up like this here. And then 2 would be 8, I believe. Like this. So something like this. And so we can look here and clearly see that there is no x-intercept, 0. And what coordinates? There's none. So we'll say none. So here's these are the only possible options. No matter where you draw a parabola, right, the happy or sad face, you're either going to have 2 x-intercepts, 1, or 0. In other words, you're going to have 2 roots, 1 root, or 0 roots. So there is a way to calculate this without graphing it. And it's called the discriminant theorem. Now, it's a little different way of how you spell the word discriminant. It's not what you might be thinking. So here's the word. Discriminant. Discriminant. So it says, suppose you have a, b, and c are real numbers, and a cannot be equal to 0. We've talked about that before with the quadratic formula. Then the equation ax squared plus bx plus c equals 0. We've had this before as well. We just set y to 0, right, trying to find the roots. Based on part of the quadratic formula, if you remember the quadratic formula, I'm going to write it out down here. It's x equals, see if you remember this, negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you remember, at some point, you split this into 2 equations using the plus and then using the minus. But if you just calculate the inside of this part here, right here, b squared minus 4ac, that's what's showing up right here. Depending on what you get as an answer will depend on how many roots there are. So for example, if you calculate this b squared minus 4ac and the number is positive, so just pretend this number was 36 inside there. What ends up happening is you end up getting 2 real roots, right? This will split into 2 different answers. Maybe you'd have like, negative 5 plus square root of 36 is 6 over 2, negative 5 minus. You're going to get 2 answers. That's if this number inside is positive. That's what that means. Greater than 0 means it's positive. If for some reason you do the b squared minus 4ac and you get the number 0, so if you do this inside here and you get the square root of 0, then it doesn't matter if you have plus or minus. You're going to only get one answer. So pretend I had this, right? It doesn't matter about adding or subtracting 0. Your answer would just be negative 5 over 2. So if it equals the number 0, that means you only get one answer or one real root. The last option is if it's less than 0 inside the square root. So let's think about a number that would be less than 0 inside the square root. What if you had negative 9? So what would that mean? That would give you an answer of 3i. So the problem is you're not going to get any real roots. These are called imaginary roots. So you would still get roots, but they're imaginary. So how many real roots would you have? 0. You would not see it touch the x-axis. That's if you calculate this inside of the square root, the part of the quadratic formula, and get a negative number. That's pretty much all we're doing. We're going to be looking at equations that look like this. We're going to be identifying a, b, and c, and just doing a part of the quadratic formula, not even doing the whole thing anymore. We're just going to do a part of it, the part that's inside the square root, and just see how many roots would there be. We don't know what the root is. We just know how many there are. That's the discriminant theorem. Oh, also, sometimes they refer to the b squared minus 4ac equal to a capital D, just to stand for discriminant. So we're going to do some problems, and I would prefer that you'd probably go back to this little box here to see how it makes sense. When we do these, we either going to get a positive answer, right? We're just going to get a number. It's going to be positive, it's going to be 0, it's going to be negative. Those are the only options. Depending on what we get, it would tell us whether we have 2, 1, or 0 roots. So I wrote out the steps in this example. We're going to try some random examples here. We have a couple examples here. And then we'll be able to wrap it up. That's really what we're practicing today. Okay, so each of the quadratic below, we're going to follow the steps of 1 through 4. Determine the values of a, b, and c. So I'm going to go through this with the first example. So a, b, and c. So a is 4, b is negative 4, c is 1. Use the discriminant formula. So the formula says b squared minus 4ac. That's all you have to remember, just the part inside the square root. So we're going to change this, and then we're going to determine how many. What are we determining? We're finding the roots the equation has. How many? So again, let's plug the numbers in. We have b is -4, so we have -4 squared minus 4 times a, which is 4, times c, which is 1. So this will give us 16. Of course, you could put this whole thing into the calculator. You don't have to do it step by step, but I'm just going to do it in my head. 16 minus 4 times 4 is 16 times 1 is 16. So we end up getting the answer of 0. So what does that mean? If I go back to my box here, if you do the b squared minus 4ac and you get 0, that means there's one real root. That's all I'm going to say. One real root. Let's see if I covered the steps. Determine how many roots the equation has, and then it says to graph this equation in your calculator to check. So we're saying that this is going to come up and touch one time at its vertex. I'll do that real quick in Desmos. It's 4x squared minus 4x plus 1. Let's see. We can delete some of these. We don't need them all. 4x squared minus 4x plus 1. There we go. And as you can see, zoom in on this a little bit. I don't know if it's, I thought it was giving me the point there. It comes down and it hits just one time at the very bottom. That's actually hard to see, but it looks like it's kind of touching multiple times. But that's the vertex at the very bottom here, and it hits it once. I'm surprised let's see if it's a table. It's got to be a decimal where it hits. 0.50 is what it's called there. Yep. Okay. Wasn't too bad. Next one. We're going to check and see if they're right. Again, go through the steps, label ABC. We've done this before. Now we're going to do the discriminant formula. So b squared minus 4ac. In this case, it would be 6 squared minus 4 times 7 times 4. That's 4ac. I don't know if you notice this, but it's 36 minus 4 times 4 is 16 times 7. It's going to be a pretty big number, so no matter what here, we're going to get a negative number, I believe. So 4 times 4 times 7 is 112. So if you subtract them, 36 minus 112, you get negative 76. And again, go back here and say, okay, well, let's see. When you get a negative answer, how many roots? 0. 0 real roots. And I'll check this one in a second. I think I'll just do the last two at the same time. And the last one, ABC, which would be 3. Nope, what did I do that for? B squared is first. B squared would be 5 squared minus 4 times A, which is 3, times C, which is negative 14. Let's see what we get there. So that would be 25. Negative 4 times 3 times negative 14. That's going to give us a positive answer, actually. 168. So negative times a negative is a positive 168. Again, you can put this all one time in the calculator. That's fine. And add the 25, you get 193. So I gave you an example of each, right? This is a positive answer. I don't care what the number is specifically, just whether it's positive, negative, or 0. So this is 2 real roots. And so we should see this one cross 2 times on the x-axis. Let's check it real quick. 7x squared plus 6x plus 4. 7x squared plus, I already forget, is it 4x? 6x plus 4. Alrighty. Oh, okay. So we can clearly see it does not touch the x-axis at all. So we had 0 real roots. That matches. And then the other one, 3x squared, 5x minus 14. 3x squared plus 5x minus 14. Is that what it was? There we go. Oh, it's pretty big, pretty long here. There we go. And so we can see it goes through some decimal places, but it does hit 2 times, and that was our answer, 2 real roots. So it does work. All right, how about something a little bit more abstract? It's really not that bad, though. And we're almost done here. We'll be able to wrap it up. Example 3. Sketch a graph of the quadratic function where y equals ax squared plus bx plus c. And so we don't have any numbers here, but we can determine kind of what the graph might look like. So we have two different things they're going to tell us. A is greater than 0, which we'll talk about what that means in a second down here. And the other thing we have is b squared minus 4ac, the discriminant, is also greater than 0. So let's go back and look at what that means. So they're saying if you calculate this and you get greater than 0, what does that mean back here? It's positive, so it's 2 row roots. So we have to make sure that when we draw this random graph here, that it crosses the x-axis twice. So let's just go ahead and put 2 dots here somewhere. It doesn't really matter where it's at. I'll just make 2 random ones. We just know that our graph that we draw is going to cross the x-axis twice. That's what this means, right? 2 real roots. All right, so what does this a greater than 0 mean? So what this number here being positive, what does that mean? Well, if a is greater than 0, I don't know if you remember this, that outside number, if it's positive, that means you're going to get the happy face. I'm just going to say happy face. So you're looking at this, right? If a is less than 0, that means you're going to get the sad face parabola. Remember, that is what determines whether you have happy or sad. So in this case, if a is greater than 0, and we have a positive number here, we're going to get a happy face. So we're going to draw it like this rather than going like this. So you can draw however you want. And there it is. So that would be an accurate description of these two things. These two, specific things that you need to have in this equation. With no numbers, we can just do a basic sketch. All right, we have 2 left to do. I might even go through one of those team huddles with you. So without drawing a graph, determine the number of real solutions. So in this case, we don't have them equal to 0, so we have to do a little bit of extra work. So let's do that. Let's move the 5x over by subtracting it. It's very important that you move it over correctly. That way, whenever you cross these out and get 0, we need to have these in the right order, and we need to make sure we have everything with the right signs. So now we actually have a -5, and that would be our b value. So we have a, b, c. So we're going to do -5 squared minus 4 times 12 times -5. Although I guess if you forgot to make the 5 negative, you probably would still get this right because you're squaring the -5. So this will give you 25 minus, -4 times -5. That's going to be positive 20 times 12. So 240. And then obviously when we add these together, you're going to get a positive number. So that'd be 265. So our answer, if it's positive, right, that means 2 real roots. And that's the answer to the question. Without drawing a graph, which we didn't, determine the number of real solutions. All right, and the last one here, you can move either one you want. You can move the 2x or the 1, or it's just or the x squared. I'll do that. Just change it up a little bit, move the x squared over. We're not factoring, so I don't care too much. 0 equals, so it's -x squared comes first. 2x is positive, so put a plus there, -1. A is -1, b is 2, c is -1. So b squared, so it's 2 squared minus 4 times -1, which is a, times another -1, which is c. All right, so we get 4. Negative times a negative is positive times a negative, so we're going to get a negative. 4 times 1 times 1, that'll give you 4. So this is going to give you 0. If you remember, the number 0 is how many roots? 1 root. So 1 real root. Make sure you say the word real, so that way we know it's not imaginary. We're not talking about imaginary roots. I do want to kind of maybe go over this one real quick with you and then have you guys finish the rest on your own. Yeah, I think you could do that. There's some mastery ones where you're going to figure out the discriminant and then just make a sketch of the graph. Again, you can use Desmos or you can use a calculator at school. Probably just use Desmos. That's the best thing to do. Type in desmos.com/calculator. Last thing I'll go over before we end this is these problems here. So again, it's just using the idea of how many roots there are. It just says sketch a possible graph of the equation based on the discriminant. Remember, if the discriminant is positive, like this, that means there's 2 real roots. I'm going to say 2RR, 2 real roots. Again, just pick 2. And this one doesn't matter if it's a happy or a sad face. You can draw it this way if you want. We just know it crosses twice. If it's less than 0, that means it's a negative number you get. That means there is not going to be any real roots. So if you want to draw another sad face, we'll just pick a vertex point that's not on the x-axis and go like this. Just a basic sketch. Not the best even. Here we go. And then if it equals 0, we know it is 1 real root. Oh, I should say 0 real roots. This is 1 real root. So it has to touch somewhere. So I'll make a dot here. And then again, this can be happy or sad. I'll do a happy one this time. Of course, mine are going all over the place. Doesn't look that great. And so that's it for the very end of the chapter, 6.10, determining how many real roots you have. And you can finish up the rest of it, and we can move on to the next chapter.